you, bro? Like, did you like sci-fi? Oh, it was like
Morning, everyone. How did the homework go? A lot of you didn't touch it, and I really want you to do the homework every day. That's the only way you're gonna basically learn this material. All right, any questions before I start? Nothing? Okay, so we are going to start we're gonna start solving some of the problems from yesterday, just to give you a head start, and you guys please work on your homework tonight. So yesterday we did what we call the washers method. It was the idea of rotating a region between two curves around the x-axis. And before we start, I would like to remind you that volume of a washer this is a washer, it's nothing more than a disc with a hole in it. That's a washer. That's the center of the disc. That's the inner radius. And that's the outer radius. And that's the height of it or the thickness of it, which is usually my delta X or my delta Y. And the volume of the washer is volume is equal to pi times, it's the bigger radius, the bigger volume of the big disk minus the volume of the little disk. And if you work out the formula, it will be the outer square minus the inner square, okay? All right, so we're going to do some problem. I saw some question, we will do that. But first I want to make sure all of you can do all type of problems. So I'm going to do, let's see, 4 problems, including the 47, and then we move on. Right, as I'm working, please, I need answers. So I'm going to look at number 25, I think. Yeah. Okay. Number 25 is easy, but it just put us back into the idea. So in number 25, we have the following curve. One going up like that, one going down. And the region is, this is the region. And this is ln of 2. This is ln of 3. This curve is y equal e x over 2. And this is y equal e minus x over 2, okay? And this is the region that we want to rotate around the x-axis. So that's my axis of rotation, the x-axis. And the way we are going to do it is we're going to take a typical piece, rectangle, and rotate every rectangle. And when we rotate it, we get a washer, and we will fill up the region with washer. So when we rotate this, that's my typical washer. Sorry, that's my disk. When I rotate it, I'm going to get this washer. That's the washer we get. All right. So we're going to find the volume of this washer, and then the idea is we're dividing the interval into this rectangle. And by rotating each one of them, we're going to fill the inside of the whole solid. So that's going to be the whole solid here. Okay, sorry. That's the whole solid. We're going to fill it with rectangle. All right, so let us get started. So this is my typical rectangle. So rotate, rectangle, give me a washer. To find the volume, we need outer radius, inner radius. That's really what matters the most. The rest is very simple. What's the outer radius? What's the inner radius? And what's the height? Once we determine every aspect, we're done basically with the problem. All right, so let us get going. And now I will ask, I want answers. What is the outer radius? Quickly put it on chat so we can do a lot of problems. That's my axis of rotation. It means that's the center of my circles right here. My outer e to the x over 2, correct. From here all the way to here. That's my outer. E to the xi over 2. What's my inner quickly? And I want all of you, not very few of you. I want all of you to answer. Okay, do you agree with your classmate? It's from the center of rotation till the bottom curve. This is my inner. This is e to the minus x over 2. It means if this is xi, from here to here is e to the minus xi over 2. So my inner is e to the minus xi over 2. My height is this little delta x. That's my height from here to here. Once you fill up all those details, basically the problem is actually fairly easy right now. So the volume of each washer, of typical washer, it means of this one, that's the volume of this is pi times. That's the height, the delta x, and that's the outer square minus the inner square. Finally, so that's a plus and that's a minus. Now, what is the total volume? So the total volume is it's the integral. It means it's the sum of those little volume. The sum becomes the integral of those dx. And this is e to the x over 2 squared minus e to the minus x over 2 squared. And the boundary, I always go to my region. I say, what should I split into pieces to cover all this with those little rectangles? I have to split the interval between ln of 2 and ln of 3. And now we are almost there. Okay. Now let us integrate. And you guys help me out. Pi is a constant. I get it out of the integral. ln of 2, ln of 3. E to the x over 2 squared, it means you square it. When you square, you multiply the power times 2. It means e to the x. So I will have e to the x minus e to the minus x dx. Now antiderivative. Pi times between ln of 2 and ln of 3. Antiderivative of ex is ex minus antiderivative of e minus x. Now here we have an inside function. So the only way to do that, we have to do a substitution. So on the side, I will do it in green to know that's what I am doing. Antiderivative of e minus x dx. U is e minus x. Du is minus e minus x dx. We have to use the chain rule. And this gives me minus e to the u du. It means minus e minus x. So antiderivative of E minus X is the minus because we need a substitution since we have right there an inside function. It's not in X. So this is going to be minus E minus X, which would give me that much. All right. And now we're done. At the upper limit, e to the minus ln of 3 minus at the lower limit. So finally, I will get e to the ln of 3 is 3. This is 1 over e to the ln of 3. It means plus a third. Minus e to the ln of 2 is 2. This is 1 over e to the ln of 2. It means minus a half. The rest is fairly simple. Question. All right. Now we're going to do problem very much like it, but I'm going to do a problem where we rotate around the y-axis, so we will be very comfortable with that scenario. Okay. So we look at 28, and there are a lot of problems. So let's look, for example, at 28. So let us be careful. Here I have the following region. Okay, where is my pencil? Sorry, I'm looking for my pencil. It should be okay. 28. This is my region. I have a line. And I have a line right there. And this is, according to them, that's 6. The line y equal to 6. This is the curve y equal x, which happens to be a straight line. And this is y equal to x. And this time, instead of rotating around the x-axis, we are going to rotate around the y-axis. So the difference is going to be, instead of taking the the vertical slices, we're going to take slices which are perpendicular to the axis of rotation. That's my axis of rotation. We're going to take those horizontal slices. It means we need to divide the interval on the y-axis into pieces, not on the x-axis. So that's the interval we're going to divide. So this is my yi. And this is the yi plus 1. So we divide. So the same principle. We cover this with a rectangle, and we rotate every rectangle. Now, when we rotate every rectangle, what are we going to get? Please, I want quick answers. What do we get? A washer, a desk? I don't know.
Disk.
Disk? You sure? You sure a disk? This is my axis of rotation. Okay, it's very whole. Are we gonna get a washer or we're gonna get disk? Right here, there is nothing.
Oh, it's a washer.
It's
Yep,
a washer.
there's a space between the y-axis.
Exactly. It's a washer because there is a space between the rectangle and the y-axis. We are gonna get a washer. So we have to be very careful what we're gonna get every time, because very soon we're gonna get another picture. So we have to get those two straight. Because there is a space, we're gonna get a washer. That's the washer we're gonna get. Okay. A disk is full. So that's a disk. There is no hole in it. It's like a quarter. It's a full. Okay, that's it. It's full. There is no hole. Washer, there is a hole. Means you take this disk and then you make a hole in it. That's a washer. Got it? Yeah, that's a disk. There is no hole. That's a washer. A disk with a hole in it, open hole. So the volume is changing. All right, so now we take a typical rectangle, we're gonna get a disc. Sorry, we're gonna get a washer. So rotate rectangle, give me a washer. And always you have to ask ourselves what we're gonna get because it's important. All right, I need the volume of this washer. Question number 1. What's the thickness from here to here? What do you think we're gonna call it? Okay, I'll draw it in green. This, what is it called?
Delta Y.
Delta Y. What do you think is gonna be my variable in this problem? X or Y?
Y.
Why? Because when we are gonna split the line on the y-axis, y is going to become my variable. Be very, very careful. No more x. Y is going to become my variable. This is my delta y. So immediately, what I'm gonna fill this out here. The outer, the inner, and the height is going to be delta y. Y is my variable in this problem. Everything will be in terms of y. Now back to you. This is my yi. That's what I know. So I'm splitting, I'm concentrating on a piece. The inner radius is from where to where? What is the inner radius? That's the picture. I usually leave this just for labeling, and this is what's really happening. The radius from where to where? In word, whatever you guys can think of. From 0 to 6, is this the inner radius?
No, it would be from the bottom of the rectangle towards the y-axis.
Right, it's from the y-axis till the inside curve. That's the radius, inner radius from here to here. That's the inner radius of the washer. Are you with me? Crucial. That's the inner radius. It's from, as your classmate put it correctly, from the y-axis, that's the axis of rotation, till the inside curve. This one, to the left curve for us. All right, who can give me a formula for the inner radius? Who can give me the inner radius is equal to what? These are my curves. For you, you know the yi. I want the horizontal distance from here to here. Everything has to be in terms of yi. In this problem, the way you think about it, I know this. How much is that horizontal distance in terms of yi? Back to you.
Yi over 2.
Yi over 2, is he correct? Is he correct? Absolutely correct. Why? Because this is y equal to x. This curve y equal to x. I know the y, but I need it's a horizontal distance. It means I need the x. So I have to solve for x in terms of y. So whenever y is my variable, I have always to solve because I usually need a horizontal distance. It means this from here to here means right here. If this is yi, this is a half yi. This is my inner radius. So my inner radius is going to be 1/2 yi. What's my outer radius? My outer radius is from the axis of rotation to the outer curve, if you want, or to the right curve in this problem. That's my outer radius. All right, what's the formula for my outer radius? Means from here to here. That's my outer radius. From here, the y-axis, yi right here, all the way to here. That's my outer radius. Who would like to give me a formula for the outer radius? Yi, absolutely correct. This is the curve y equal to x. It means if this is y, this is the same distance. That's really what it means, the line. Now I am done. Basically, once we figure out those, there is nothing into the problem. So volume of a typical washer is pi times delta y is my variable. There is a delta y because I split the interval along the y-axis of the outer radius square minus the inner radius square. That's for every washer. Now the total volume is, we add the volume of those washers. It means what we're doing at this stage, we are filling this with those washers. So something like that. And we are adding their volume. So that's really the picture. I mean, it's like we're filling it with those and we are adding the volume. This plus this plus this plus this plus this, the whole thing. That's really the picture at this stage. So now it's pi times. This is my dy. Yi squared, it means y squared, minus a half yi squared, it means a half y times a half y, means 1/4 y squared. Now, what are my limit of integration? I go back to my picture. What are my limit? Now you ask yourself, which interval I need to split into pieces to cover this whole region with rectangle from 0 this time all the way up to 6. And these are my limit of integration. So once you really draw the picture, that's really what it boils down to. Draw a good picture, figure out this, you're done. There is nothing else into the problem. And now the rest is easy. This is an easy integral. Pi is a constant, I get it out. Antiderivative of y squared is 1/3 y cubed. Actually, I can combine those, sorry, my apology. Pi, integral from 0 to 6, pi squared minus 1/4 is 3/4 pi squared dy. Then I will be left with 3 pi over 4, 1/3 y cubed, evaluated between 0 and 6. And the rest is easy, okay? All right, now we look at number 47, and then we proceed to the same idea, but with a slight variation of it.
Professor, can I ask a
Yes.
question for this one? So basically, instead of taking horizontal slices, could we take vertical ones?
This will be the next section. Because if we take vertical, we will have a different shape. We will not have a washer. And that's the content of section 6.4.
Oh, I thought if you take vertical, it will be again like cylinder. So.
No. Now, if we take vertical, especially in this problem, we have two issues. We will not have a washer. We have like a different picture. And as I said, next section, I will. First, there are two issues with the vertical. Issue number one, that when you take vertical, the curves, the top curve is changing. That's problem number one with vertical. Problem number two is that we will not get a washer when we rotate this. We're gonna get another picture that we're gonna call cylindrical shell that I will explain in the next section. And then, what?
Yeah, I see.
Yeah. Next section, this problem will come up very soon. And then you guys will have the freedom of taking the slices you want. For now, let us stick to that. Okay. All right. So where am I? All right. Now I'm going to look at number 47, and then you guys will finish the homework. By now, you should be able to do it. Let me look at number 47. What is it about? 47. For the following region, determine, that's the question, determine which is greater, the volume when the region is revolved about the x-axis or about the y-axis. So we have the following region bounded by y equal 1 minus x cubed, the x-axis, and the y-axis. So this is my region. Y equal 1 minus x cubed. Let's remember how it works. We know how x cubed is. This is x cubed. Minus, it means we reflect across the x-axis. 1, basically, we lift it up a little bit. So it's going to be lifted to 1. It's going to look, this is the piece here. something like that. So that's y equal 1 minus x cubed. The x-axis and the y-axis. So that's the region of concern. So this is y equal 1 minus x cubed, right? So this point, x equal to 0, y equal to 1. And this point, if y is 0, x also will be equal to 1. So this is my region. And the question is, when is the volume larger? When you rotate it around this, or you rotate it this way? Honestly, I don't know. I'm going to compute both of them and see which one it is, all right? So we're gonna rotate first about the x, then about the y, and then see. So first, we're gonna rotate around the x-axis. All right, so this is my region. I'm gonna rotate it. So again, I will take slices which are perpendicular to the axis of rotation. So this is my 1 and this is my 1. I'm gonna take slices perpendicular to the axis of rotation. It means I'm going to, this is my axis, that's my rotation, that's my xi. And I'm gonna rotate this piece. Question number 1, if we rotate a rectangle, what do we get? A washer or a disk? Quickly.
Yes.
Disk, because we're touching the x-axis now. So there is no hole in between. Okay. So that's basically a simple problem. Question number 2. If we need a disk, what characterizes disk is the radius and the height of the disk. We don't have, since there is no washer, there is no inner and outer, there is only a radius. So what is the radius of the disk? And what is the height? And what's the variable in this problem? X or Y? Quickly, all of you.
X.
Which interval we're splitting into pieces? We're splitting the interval along the x-axis because we're covering it with those vertical slices. So this is my xi. This is from here to here is the delta x. And this is the curve y equal 1 minus x cubed. So now the question, the height is the delta x. And what is the radius? Quickly. What's the radius? Okay, I know you guys know, but you don't want to answer, so I'm going to pick one of you. Joseph, what's the radius? Joseph, are you with me? Okay, I move fast if student doesn't answer because I don't want to hold like 1 minus x cubed. All right, this is xi. The radius is from here to here. That's the radius. 1 minus xi cubed. Now I am there. I'm done. Basically, volume of a radius, volume of a typical disk is pi times the radius square times the height, because it's a volume. And this is 1 minus xi cubed. So now the total volume is the integral. The interval should be from 0 to 1 of pi times the x, and this is 1 minus x cubed, okay, which is equal to, oh, that's okay. Just put it on chat if you can't answer. Just put on chat. Okay. Now, how I'm going to integrate this piece? 1 minus x cubed square. Back to you guys. Put on chat if you guys don't have a microphone. How can I integrate this? I need to integrate. What would you do if you guys have this problem? Exactly. We will have to distribute. So let us distribute. 1 minus x cubed to the power 2. So you guys distribute, you should get 1 plus x cubed squared, give you x6, minus 2 x cubed dx. Okay, there is no way out in this problem except distributing. And finally, I will get pi times x, the antiderivative, plus antiderivative of that 1 over 7x to the 7 minus antiderivative is 2, 4x4 evaluated between 0 and 1. All right, so this is going to be equal to pi times 1 plus over 7 minus a half minus 0. So this will give me pi. Common denominator has to be 14. I will have 14 plus 2 minus 7. You can take any of my stupid mistakes. So finally, I will have 16 minus 7, 9. I'll have 9 pi over 14 if I rotate around the x-axis. Okay. Now, what happens if we rotate around the y-axis? What will be the problem? All right, now same region, rotate around the y-axis. So we're not changing, we are rotating. Please, if I move the paper fast, let me know. It's up to you to let me know what's really going on. I don't see your faces, I cannot judge easily. Next week we're back, I will be able to be a better judge. So now B is rotate around the y-axis. The same region, but we're going to change the rotation. One, y equal 1 minus x cubed. That's the axis of rotation in this scenario. Now I'm going to move this. And since I'm rotating around the y-axis, I'm going to divide the interval along the y-axis into pieces. So I'm going to take those horizontal slices. And this is my yi. Okay, question number 1, what's going to be my variable, x or y immediately? Because I don't want any more confusion with that. That happens. So y is going to become my variable because I'm dividing this interval. So everything has to be in terms of y. There is no more axis in this problem. Now, if I rotate this rectangle, what do I get? A disk or a washer? Remember, I'm rotating around the y-axis. We are rotating this rectangle. There is no hole because my rectangle is touching the axis of rotation. There is no hole or whatsoever. So I'm going to rotate. I'm going to get my disk. Now, disk, to find the volume of a disk, we need the radius. There is no inner and outer in this case, and we need the height. The height is from here to here. Height of my disk, that's my delta y. What's the radius of my disk? It means that's the radius, because when I'm rotating this one around here, that's going to be the radiuses, because that's what I'm going to get basically. I'm going to get that. The radius is from the axis of rotation, right there. This is the horizontal distance from the axis of rotation till I hit the curve. This is the radius. How do I get the radius? This is my yi, that's the given to you, and I need this range in terms of yi. Quickly give me the radius. No. No, the answer is not the right one, and you think why that's not the right one. What is the radius? What do you have to do? Exactly. Julian, can you speak up? Or your microphone doesn't work?
Yeah. You just have to change the function.
Not change. Put it better. Your answer is correct. It's not change. What do you have to do?
Convert it so that it's in terms of
Not
y.
converted, not converted. Do it better than that. even though your answer is correct.
Solve.
Solve,
Solving.
right. What do we have to do? Solve for x in terms of y, all right? Because changing, it means you put x here, y here, which is not the correct thing. We have to solve for x in terms of y. So your answer is correct, but the written one, but what you have to do is we need to solve for x in terms of y. So to find the radius, we need to solve, because in this problem, I know the vertical one. I know the horizontal. Whenever I need the horizontal distance, it means I need the x in terms of y. So the question is, we have to solve, not change. We need to solve for x in terms of y. Okay. So we have y equal 1 minus x cubed. I need to solve. This would give me x to the power 3. I move the x here, 1 minus y. It means my x is, as you put it correctly, the cubic root of 1 minus y. Okay, so be very, very careful here. So the radius now is the cubic root of 1 minus the yi. So everything in terms of the y. Now the problem is simplified. Volume of a disk is pi times the radius squared times the little height. And here is the cubic root of 1 minus yi. Now the total volume is the integral. It means the sum basically of the little disk. That's my dy. And that's the cubic root of 1 minus y squared. And then of course, we're going to simplify the whole thing, but now we're setting it up. And my boundary, to cover the region with those rectangles that I'm going to rotate each one of them, I have to divide the interval from 0 to 1 as well. So from 0 to 1. So this is equal to pi is a constant, 0 to 1. Now I have this quantity that looks really like a mess here. First, we have, you know that integration doesn't like a cubic root and all this stuff. So we're not going to write cubic root. I'll write it exactly like your classmate wrote it. That's 1 minus y to the power a third. So we have 1 minus y to the power a third. The whole thing, you square it. It means 1 minus y, a power to the power, you multiply the power to the power 2/3. And that's what give me to the power 2/3 dy. Okay. Now I have to integrate. How would you integrate this quickly? I will stop once I get you going, then I will stop and move to another idea. How would you integrate that? Back to you. U substitution, absolutely. Since I have a u in here, I have to make a substitution. So I'm going to put u, 1 minus y. The du is minus the dy. So it's equal to pi times 1 minus y is u to the 2/3. dy is minus du. That's my minus here to du. Now I'm going to change the limit. If y is 0, u is 1, so I'm going to get a 1 here. If y is 1, that's going to give me a 0. All right. Now, I know that you guys don't like 1 and 0, but since I have a minus in here, I can use the idea that the integral from a to b is minus the integral from b to a. So minus 1 to 0 would give me plus from 0 to 1, u to the power 2/3 du. And the rest basically is fairly simple. There is nothing into the problem anymore. Antiderivative of that is 1 over 2/3 plus 1. 2/3 plus 1, which is going to give me 5/3, so it will be 3/5. U to the power 5/3, evaluated between 0 and 1. So this would give me 3 pi over 5. And now you compare it to the other one. 9 pi over 14, the bigger one is the bigger one. End of the question. Okay. All right, so this is a good review for the homework problem. Please make sure to do them for tomorrow. I mean, we're going to do more problem today, but make sure to finish your homework. Don't be behind. You will be lost. All right.
Prof,
Yes.
did that negative in the first line that's in red in front of the pi
Yes.
come from the du is equal to negative dy and you just pulled
Exactly.
it out? Is that correct?
Yes. Yes. Yes.
Okay, thank you.
Yes, absolutely. Any other questions? Right now, what we are going to do is we're going to do also rotation, the same ideas, but instead of rotating around the x and the y axis, I'm going to rotate around a different line. Not any different line, but a line which is parallel to the x and y axis. Everything is going to be the same, and you guys are going to solve those problems almost yourself. I will just tell you what we're doing. So this is my problem. So revolving about an axis. So rotation about different axes. About lines parallel to the y and x axis, to the x and y axis. Okay. All right, so this is my problem. Find the volume of the solid obtained by revolving the following region. Bounded by the graph of y equal x squared, y equal root x, but now the line is around the line, not the y equal -1. Okay. That's the problem. So we're going to draw the picture a little bit. So I'm going, instead of doing the x-axis, I'm actually dropping down the axis of rotation. It will be the line y equal -1. So let me start by drawing. Okay. The curve y equal x squared. Okay, we all know that's a parabola going up like this. Y equal root x, that's a parabola toward the x-axis. So this is my region. And the axis, and this is the x-axis, but that's not the axis of rotation. The axis of rotation is the line y equal -1. This is -1. This is the axis of rotation. Important. Okay, that's the axis of rotation. And we're going to rotate around this axis, not around the x-axis. Right. First, let us see what's the intersection, because we all know we need the intersection. So the intersection is, actually, we should know that, it's easy. X squared equal root x. And now, because I have the square root, we need to square both sides. It will give me x4 equal to x. Now, to solve this, x4 minus x equal to 0. We factor out the x cubed -1 equal to 0. It will give me x equal to 0, x cubed -1 equal to 0, x equal to 1. So this is my 0, and this is 1. If this is 1, the second coordinate, whether you plug it here, it's 1, you plug it here, it's 1. I have my region. So that's really the easy part. Now, the principle. So we're going to rotate this. And the rotation is, so this is my axis of rotation. So it's going to go down here. I'm changing the axis. And this will be like that. The whole thing is changed. We're going to get this weird figure. Okay, that's really what we're going to get when we rotate. Okay. right? So it's very different. That's my axis rotation. So now the question is how we're going to find the volume. The principle is verbatim the same. I will not even change the principle. The idea is, okay, what shape we're going to get when we rotate a typical rectangle, and then we go from there. All right. So let me draw a better picture again, just so I can. So this is my curve. Okay, and this is my line. That's the rotation. This is -1. And this is the x-axis. Okay. And I will do exactly the same. It means I'm going to take, since I'm rotating around a line parallel to the x-axis, I'm going to take those vertical slices. So this is my xi, and this is my slice. And this is the slice I'm going to rotate. Be careful. This is the axis of rotation. So I'm going to rotate. So this is going to go all the way down. That's going to be the center right there. And I'm going to rotate. It's going to go all the way down. That's the center of, if you want, of my shape. So question number 1. When I take a rectangle and I rotate, what do I get? Back to you. Desk, washer, what do I get? I'm listening. What do I get if I take washer? Do you agree with him? We have a big, huge hole here. So we definitely gonna get a washer. Absolutely a washer. Okay, we have the big hole. Big hole. This is gonna be empty here. This piece is gonna be empty right there. Question number 2. If you have a washer, to find the volume of a typical washer, I need the inner, I need the outer, and I need the height of the washer. So once I determine all those pieces, I am practically done. Inner, outer, the height of the washer. Right. The easy part is the height, because the height of the washer is going to be from here to here. This is my delta x. Now the harder part. What's the inner and what is the outer? First, let me focus on the inner. I've been calm. I want you to guys to remember. So this is my xi here. And who can tell me what the inner radius is? Think a little bit. Look at the picture. Look at the picture. This is the center, if you want. So that's my axis of rotation. So the center of washer is on the axis of rotation. Is on this axis. Now back to you guys. Every one of you, think a little bit. What is going to be the radius? It's from where to where? Question number 1. It's from where to where? In Word. It's not hard. It's absolutely not very hard. David. Okay, so David and Sammy, both of you gave me the correct answer. The inner radius is from the axis of rotation all the way to the inner curve. This is xi, so it's going to be from here to here. What you're basically doing is translating. You're pushing down the axis, so you're making the radius bigger of the inner radius. So it's from here all the way down to here. That's the inner radius. So this is it from here to here. That's the inner. So what's the inner radius equal to? Now let's remember, if this is xi, this is xi squared, because that's y equal xi squared. So in my picture, in my mind, this is xi squared. But what do I need? I need the distance from here to here. So it's xi squared plus 1. So we're increasing by 1. So the inner is xi squared plus 1. Just really, really look at the picture. Really look at the picture. That's really what the inner radius is. Now, so what's the outer radius now? What's the outer radius? I guess we got you all started. I want other students to participate. What's the outer radius? From where to where? Remember, it's this whole rectangle, this whole thing, I'm gonna really rotate. William W. Wojciska, sorry, William. Are you with me? Yes, what was the question again? What's the outer radius? Look at the picture. So this is the whole thing. Imagine, just imagine your head. You're taking this and you are rotating. So think about this point here. This point, think about this point. If you're, yeah, absolutely. It's from here all the way down to the line y equal to 1. This is the outer radius. That's my outer radius. But this point here, if this is xi, this is a point on the curve y equal root x, so this is the square root of xi. So the distance from here to here is the upper part square. Logically, square root of xi, you add 1 to it. That's really just by looking at the picture, nothing deeper than that. So it's the square root of xi plus 1. Now you're basically done with the problem. Why? Because volume of a washer, actually the total volume, is going to be the integral from 0 to 1 of pi times the outer minus the inner square and of the problem. Okay, and now to evaluate this integral, you need to distribute this, distribute that. It's a little bit of math, but not hard math. That's actually easy math. All right, so please do the homework. I'm going to assign 3 more problems for tomorrow, which relate with that. Please do the homework and ask questions. And for this particular section, my notes are also on Brightspace. Check them out if you want. All right, class is over. Anybody with question can stay.